All right, here is the help video for questions 2, 3, and 5 on the individual test from chapter 11. And we'll start here with question number 2. Now, I'm not going to work all the way to the complete answers, but I do want to just provide some guidance through the more challenging steps of each problem. Now, this one here, since we're looking for surface area in problem number 2, what we want to do is find the area of each face and add it together. Now, I see 3 different types of faces in this problem, and the first one I see is that first face, which is the front and back of the shape, and that is 8 and 20 because 8 is the length there and each lateral edge has a length of 20. That would represent the front and back of the pyramid. Second one is the right and left of the pyramid, which this is 12 and 20. Okay, sorry for my marker changing colors, my computer's acting funny, but we're just going to roll with it. And then the last one is just the bottom of the shape, which is 8 by 12 rectangle there. Now, for these two triangular faces, we need to find the height of each so that we can end up finding the area of each, and that's what we're going to work through. But before we do that, we're going to find just the area of the base because of the rectangle. All we got to do is length times the width, which in this case would give us 96. Okay? Now, that's pretty good. We'll use that later. That'll be something we'll add on, but we'll go back up to the triangle and we'll start with this one here. Now, to work with this triangle, we want to split it in half so that we work with the right triangle that looks something like this, where we split it in half, draw it down. The lateral edge is still 20, but now the base is 4 because we cut that in half, and we need to Pythagorean theorem this. 20 squared equals 4 squared minus x squared to find that height x. Okay? Once we have that height x, we can find the area of this triangle. This would be 20 squared is 400. That's 16 minus x squared. Excuse me, it's plus. Pythagorean theorem, a squared plus b squared. Come on now. Okay. I can subtract over the 16. That gives me 384 equals x, and then, x squared, and then I can square root this to find the height. Okay, so the height of that is the square root of 384, and let me just grab my calculator quick to see that one, and then that's where I'm going to leave this one for you to continue on to finish it out because this should be enough of a hint to continue on. That square root of 384 gives you a height of 19.59 or 19.60 as some would round it to. Then to find the actual area of the triangle, we're going to take 1/2 the base times the height. That's 1/2 times the base, which is 8, times the height, which is 19.6, and that's going to give me the area of that front-facing triangle. Now, since there is a front and a back there, you are going to have to multiply that area by 2 to represent the front and the back. You will do something similar with the right and the left triangle. So this triangle here, the left and the right face, find the area, multiply it by 2 because we have to take into account the right and the left there. Now, for problem number 3, we are looking for the volume of this ice cream cone. Okay? Now, there are 2 pieces to this ice cream cone. There is a half sphere or a hemisphere, and there is a cone. To do the hemisphere, we are going to use 4/3 r cubed times pi, the equation, to represent the area of a sphere, and we're going to divide that in half. Now, since the diameter of this circle is 12, the radius would then be 6. So I know my r in this problem is going to equal 6, and I can even find out this hemisphere right away. For 4/3 times 6 cubed times pi divided by 2 will give me the hemisphere. Okay? That'll give you, let's call it hemisphere area HA. To find the cone, what we do to find a cone is we take the base area times the height and then divide it by 3 because really a cone is a circle-based pyramid. Now to do that, we need to actually find the height of this cone because 10 is not the height, it's the slant height. We need the actual height, which is another right triangle problem looking something like this. This is 6 because the 12 was cut in half. This is 10, and if you remember your Pythagorean triples, that would tell you that this right here is 8. So what you're going to do is you are going to take the area of the base, which is pi times the radius squared, times the height of the cone, which is 8 from what we just did, and we're going to divide that by 3 because that's what we do with pyramids. Okay. In both cases, the radius is in fact 6. You will find your hemisphere area by doing what's on top. You'll find your cone area by doing what's on bottom, and then you're going to add the cone area plus the hemisphere area to get total. Sorry, I'm saying area, and this should seriously say, and I'll erase it, I'm glad I caught the mistake, hemisphere volume and cone volume. Okay? And because we are finding volumes here, and these equations represent volumes here, okay, of cones and hemispheres. But you'll take your hemisphere volume and you'll take your cone volume and you'll add them together to get the total volume of the entire thing. In the last one, we have 2 different ways that I like to see this problem, but we're going to go with this way just because I'm more familiar with it at this point. The entire arc here is 80 degrees. And that then tells me, because this middle line is a diameter which cuts circles in half, that this distance here is just 40 degrees. Okay? If that's 40 degrees, then this major arc that's part of the tangent and secant line created there must be 140 degrees, because 140 and 40 would create the entire 180. And if that's truly the diameter like it says it is, then we know that a diameter cuts a circle in half, and there's 180 degrees in total right there. Once I view it as that secant line and the tangent line, and I know these measurements, I can use the formula 2x equals b minus a to go on to solve for this angle right here. B represents the major arc, which is 140. A represents the minor arc, which is 40. And then x actually represents this angle that's missing. So as long as we plug in the correct measurements and for B and A, we'll be able to solve for x and get our final answer there. That's all I'll do for now. If you have more questions, we can address them in another video, but this should hopefully be enough to have you move along swiftly and answer questions about the problems that exist here in 2, 3, and 5.